Okay, so let's continue on with this worksheet. All right, this time I would like to focus on the impulse part of the worksheet, this one here. All right, the impulse part of the worksheet. Force and impulse are the same thing. All right, so if you actually follow my class, you know that force and impulse, force, impulsive force, is actually the same thing. It's just a play of words. All right, which I don't really like. Okay, I'm sure you heard me say that many times. Okay, okay, before you can actually start impulse questions, impulse worksheets and questions, all right, two equations you need to know. All right, first equation is ft. All right, if you recall from my notes, ft is actually impulse. Okay, impulse, okay, equals to the change of momentum, which is mv, final momentum minus initial momentum. All right, okay, this is where things get confusing. All right, that's if you look at most exercise books, notebooks, and revision books, they says that there's something called impulsive force. All right, impulse force. All right, it's not impulse, it's impulse force. The equation is very simple. Excuse me, it's very simple. It's the same equation as impulse. You just move the t down. Right, mv minus mu over t. All right, so it just says that impulse force is the rate of change of momentum. All right, impulse is the change of momentum. Impulse force is the rate of change of momentum. But if you were to look at this equation carefully, I'm just going to simplify it for you. Mass, I factor out the mass, v minus u over t. Remember, final velocity minus initial velocity over time will give you mass equals acceleration. So hey, look, it's just force. So just why add the word impulse there? These are the things that I think confuse some students sometimes. All right, by adding the word impulse then impulse force, it's just the same thing. What I'm trying to say. Okay, impulse force is just force. All right. Okay, so let's take a look at one question here. It says that a pitcher throws a 200 gram baseball with a speed of 15 meters per second. The ball is hit by a batter using a baseball bat and returned to the pitcher at 45 meters per second. What is the impulse acting on the ball? It says impulse, not impulsive force. Okay, so let's try this. Let's write out the equation. Ft equals to mv minus mu. All right, it's the first one, this one here, not the second one. Okay, so mass, what is the impulse acting on a baseball? What's the initial mass of what's the mass of the ball? Doesn't change, so 0.2. Okay, v minus u, what's the final 0.2? What is the final velocity? The final velocity of the ball is return to the pitcher 45 meters per second. All right, okay, what's the initial velocity of the ball? The initial of the velocity of the ball is 15 meters per second. All right, so this is a plus sign here. Okay, so some of you ask why I use a plus sign. It's because, all right, the ball initially was traveling one direction, assume it's 15 meters per second, and now it's going back at 45 meters per second. All right, so because I set my right hand side, I set the ball going right hand side initially as negative. So negative, you get a positive. All right, so if I were to solve this, I will get 60 times 0.2. I'll get 12. Okay, 12 kilograms per meters per second. All right, so that's part A. All right, part B. Find the force acting on the baseball bat if it's in contact for 0.03 seconds. So once again, you already have this. Just use the same equation. F equals to mv minus mu over t. Now we're going to use, this is the second one. Just move the t down. We already found what is mv minus mu, which is 12. The time is 0.03 seconds. Okay, so the momentum is 12 kilograms per meters per second. All right, divide by 0.03 and you get 400 newtons. All right, that's how you do an impulse question.